Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald en ik zit zoals altijd met...
Hallo Ronald.
Hoi Jan.
Hoi Jan. Oh ja, dat was ik.
Ja, Jan Stomphorst. Ja, nee, ik help je wel even herinneren. Geen probleem hoor, kleine moeite. Hè?
Dankjewel.
Hey, we zitten hier op Tech Nation.
Alweer?
Ja, alweer. Ja, we blijven maar gaan hè.
Als een dolle.
Ja, en ik heb net een leuke talk gezien van Nicolas Braga.
Mooi.
Yeah, well, I'd like to introduce Nicolas. Welcome to our podcast.
Thank you very much.
And Nicolas, can you please introduce yourself to our listeners?
So, guys, I'm Nicolas. I'm actually a Brazilian living in the Netherlands a couple of years already. I'm a solution architect at Essent. Graduated in computer science back in 2012 and, specialized in cloud computing at AWS.
And how did you get started in the IT? What was your passion that...
Gaming, basically.
So that's always a good one, yeah.
That's always how it works, right? No, I was very into a very specific game called Tibia, and I wanted to host my own game. I wanted to host my own open service, and I was like, the only way to learn about it is learning how to program my own game.
What is Tibia?
It's a bone in your leg, but also the name of a game.
Yeah, and what kind of game is it?
It's an MMORPG game.
Okay.
Was it like in the Ultima days, or?
Yeah, it is quite a old game. I guess it had 24, 25 years, something like that.
Yeah, it's around that area of Ultima Online and stuff, I think, or maybe.
Yes, even before, probably.
Yeah, cool. And you had. Oh,
sorry. And you started to host that game, and what did you use? What
I was 16, so there was a huge community of open source of this game already. I just downloaded my own version. I learned some tutorials on the internet how to host it, and I start doing it. At one point, I was like, "Yeah, cool, it works, but it's not the game I want. So I want to make some modifications on it." And I start checking some scripts, and now, okay, very nice. I want this item to be different, so how do I do it? And I start learning about it. It got my attention. I was 16, and then I decided, computer science is what I want to do because I want to go gaming.
Yeah, cool. Yeah. A lot of kids are nowadays doing it with Roblox and Minecraft. You have the same ideas.
Yeah.
Cool. You have a talk here about how an outage sparked a full rethink of Essent's cloud infrastructure. An interesting title. Can you tell us more about it?
Oh, definitely quite interesting. So I was actually 1 month in the company when this outage happened. It was
good stress test.
Very good stress test. It was the I have faced many outages before, but this was by far the longest. Right. So it started by us not actually knowing what was causing it. It was a huge load peak in our landscape that was not going away. We thought it could be like some DDoS attack or so, but it turns out it was actually legitimate traffic due to the Ukrainian war. So energy prices became some of out of nowhere very hot topic, and people wanted to check their prices and their consumption very frequently. Our landscape wasn't just prepared for it. We had only, mostly vertical scaling. So we couldn't just accommodate the load. It took us 13 days to recover.
Wow. That's a long time for a company like that.
You had 13 days outage?
We had a 13 days outage.
So people couldn't connect to your backend or couldn't...
To the entire landscape. We even had to shut down the call centers because, and listen, we have a entire floor for a call center. There are like hundreds of people working in a call center, and it was so overwhelmed to be there that the business decided to shut it down. We went to the news. We were on the national news and journals and everywhere.
Interesting stuff happening. Yeah.
Now I think I have enough scares to scare an outage. Yes.
So, what can you tell us? Can you tell us a little bit about the infrastructure that Essent uses, or what choices there are made?
Yes. Right now we're transitioning. So we're moving from a very old school infrastructure on mostly relying on SAP and CMS and TIBCO applications, and we rebuilding it all into a serverless technology. So ECS and Lambdas, basically.
Okay.
Yep. Yeah.
And if you take us more and more in in your talk, can you also tell us a little bit more of how did you discover the problem and how did you solve the problems? But I can imagine when you find the problem, it's not very clear how to solve the problem.
No, exactly. So, the real problem was the load, right? We had a huge load, more than hundreds of times the load we used to, and we couldn't just scale it. So the very first solution we had to actually solve it was putting a queuing in between. So we actually did those ourselves, but in a nice way. So you put a queue in front, after a week of outage, we actually got a grasp of how much load our services could support before it start falling apart. So we put a queue. Just before that, we knew, okay, this amount of users we can actually handle. At the same time, we had a queue, so at least a couple people could access our landscape. And immediately after, we started also refactoring some of the most problematic APIs so that they could horizontally scale instead.
Okay. And that was also in the platform you were using were the Azure container platform, right? Or
No, we at Essent we run on AWS.
AWS. Okay.
AWS, yeah. So most of our infrastructure was on virtualization in the cloud, so EC2s.
Okay.
And running proprietary applications there. So some of those applications, they by design have to run in one instance. They don't run on multiple instances. They're not meant for it.
Mm-hmm.
So we took the 5 most problematic APIs, the ones that we saw. Those can't actually support the load. We rebuilt them actually in a different stack, in a different technology, to actually go and have it working and supporting more load. So we rebuilt them in 1 month. It took us 1 month to rebuild those 5 APIs and everything. That's super fast, right? It was very impressive. In 1 month, we managed to increase the capacity of our landscape in hundreds of times by those 5 more problematic APIs.
Yeah, that's impressive numbers.
That's very
impressive. And did you do it with your own teams, or did you call in help?
No, our own team. We, of course, as an outage of this magnitude changes the way business see IT, right?
Yeah.
So we put our effort on it. We had a feature freeze, and we're like, guys, this is the very most important thing we have to do. So we had a full dedicated team, many people working together on extracting the business logic of those APIs and rebuilding them, testing, comparing, doing canary releases, testing both side by side, and we worked quite some extra hours to actually do it. But yeah, one month is quite impressive.
And why did you go to serverless instead of containers?
Well, it's simpler to do on a serverless. So
it's still containers in the water, but of course.
It is still a container, but we don't manage even the container. So that is a abstraction layer on top of it. Of course, it doesn't fit our use cases, right? So just for you to understand what Lambda is, a Lambda is nothing more than a container that you have your initial point as the application you're running. So it's a script that you don't need to have a Docker file to actually run it. You deploy this script directly into the Lambda service, and the Lambda service create a container around it and let it run for you.
Mm-hmm.
So you don't need to think about memory. You don't need to think about many aspects in there. Well, you do need to think about memory because, if you put too little memory in there, then maybe your service won't actually run. But you don't need to say like, hey, I need this amount of instances running. You have the concept is that you run your code. So the very first run of a Lambda will spin up a container.
Yeah.
That container keeps alive. So the very next request goes to that container. If that is a container busy with a request and another one comes in, then Lambda will automatically spin up a new a server for you, and a new one, and a new one. So if you have 4 services, the 4 services needs to be busy so that a new one will spin up. And to the point that you don't have this node anymore, let's say after 3 or 4 minutes, where you have a idle container, that container will automatically shut down. So this is the concept of Lambda under the hood.
Okay.
Okay. And so do you have problems with latency?
Oh, you have something called cold start. Cold start is like the time it takes for a request to come in and the Lambda to actually be ready. Because, the request comes in and you have like a... You have a time for the service to actually go download the Lambda and make it ready to receive the request. So this cold start is a problem. There are many ways to go around it. You can always keep a Lambda busy. You can always do like some dump request to it so it keeps warm. And there are some strategies you can have as well to preload less stuffs. So the Lambda actually has lower.
Okay, but that's the cold start. But also you're abstracting a lot of things away. Are you still doing? You're putting something in AWS that AWS runs, so you've got some network latency also.
You could have network latency. So there are many ways you can configure a Lambda. You can have a Lambda in a VPC, so it's inside your own network, or you can have it on the AWS Backbone VPC. You can have those 2 flavors. If it's on AWS Backbone VPC, then the latency is it doesn't depend on your network configuration. It's on AWS. It's the same latency. Actually, it's the same latency that a public AWS service would have because you're running on the same network. If you're then running on your own private network, what AWS actually do is that they put a elastic IP in the middle, and it reuses this IP as like a IP pool. So, in the sense, you're using the same network that any other service do. So if you have a EC2 and that EC2 have a elastic IP, it is using the same resource, the same elastic IP that your Lambda will actually use under the hood.
And do you have then a limitation? Do you need allocate a complete subnet for your?
Not at all. Depends on your use case, right? So let's say I have a database and my Lambda will actually access this database. So then I have to have my Lambda inside my own VPC because the database is in my VPC and I cannot access it, right? So that is a limitation. AWS is very clever with the way they do it. So they will reuse a IP, elastic IP for multiple Lambdas. And when that elastic IP is getting to the limit, they will spin up another one automatically and that goes in a pool. So you can have hundreds of Lambdas using like a 2, 3, 4 IPs only.
It depends how much ports there are available.
Depends on how much ports, how much network traffic is going on. But in essence, if you're not needing it, if you're only handling and communicate with public services, including public AWS services, you don't need to be on a VPC. And then your limitation is only a virtual limitation of the account.
Okay. That's awesome.
It's super clever. We work at one of the companies I worked at. We used to do like content recommendation for people in the school. So we would learn how people react to exercises to kind of get a grasp on what they're lacking of knowledge, and then start recommending exercises for them to improve in that knowledge. Quite a clever solution. But what was running under the hood were Lambdas with millions of requests. So every people make an answer or getting a next exercise or so would go to those Lambdas. And at peak hours, we would have 35 million requests per hour. That is quite a lot that Lambdas can handle. And 35 million requests would fit in around like 100 Lambdas only. So it's quite clever the way they do it.
Yeah, that's. But I'm still thinking how does this compare with Kubernetes? And I think Kubernetes runs under the Lambdas, of course. But how? What made your decision to go to serverless and not Kubernetes services?
Well, basically need, right? So Kubernetes is very good when you need to optimize for communication, internal communication, and if you have some very heavy queries, some very processing working on, and you really need to optimize for networking in there between Kubernetes, communication between them. If you don't have these needs, if you're that was the case for us, we had a very straight process. We receive a request, and
It's
we
the
dispatch
workload.
it.
It's the type of workloads
The type of workload will define.
that fits in serverless. So your workload, the best workload that fits in serverless is question response.
Yes. And it needs to be fast.
Bij ACC ICT staat alles in het teken van continuïteit waarborgen voor bedrijfskritische applicaties. Of het nu gaat over Managed OTAP, Cloud en Kubernetes, ze geven hier invulling aan om door samen met hun klanten een toekomstbestendige strategie uit te stippelen voor het gehele proces van ontwikkelen tot en met productie.
So there are some hard limitations in Lambda. So for instance, if you're taking a process, let's say we're talking about a batch processing, right? And you take a batch process to process in a Lambda, it must finish within 15 minutes. Your Lambda will die after that.
Okay.
So that would be a reason to go to Kubernetes or any other type of container, right? If you have a use case, and we had some of those use cases in the past as well, where you just need to process a very long batch, and you know this process will take more than 15 minutes. You know that sometimes you need to spread this process. You need to take a master and put the process to be actually work it on other services, right? And then those type of communication, you take a part of your job, you send there, and they send to multiple other nodes, and they need to return you something. This type of communication is not actually a good fit for Lambdas. One thing you need to know, Lambdas, they charge you by this millisecond. So
Good to know, yeah.
yeah. So it's you're charged by the millisecond times the amount of memory you have, and that is so if you're running one Lambda and you want to put it, let's say, a thread in there, and you want this Lambda to divide and conquer and have multiple Lambdas actually working, then you multiply your cost, right? So you have one Lambda. If that Lambda triggers another one and I wait for that Lambda to finish, you're paying for the Lambda that is waiting for it and the Lambda that is processing it.
Yeah.
So it can be an expensive
It can
endeavor.
be expensive.
Yeah.
So here is actually the way I look at it. If you have a very sporadic load that you cannot predict, let's say you have a huge peak of load at one moment, very little load on the other, definitely go for Lambdas. Let's say you have an API that have a load you cannot predict, go to Lambdas, it will actually be cheaper. But if you have a very, very consistent load, the load is always, let's say, 300 requests per minute throughout like 10 hours a day. A Lambda running for 10 hours or multiple Lambdas running for 10 hours will be much more expensive than a container running for the same amount of time. So also, the load you put in there, the type of load matters a lot.
Okay. That's good to know.
Yeah.
And
Great takeaway, yeah.
yeah, With Essent, so always people are watching the prices. So that's a one-time call.
That's a one-time call. Yes.
So that's easy. I'm asking a question, getting a question back, the answer getting back. That's perfect for Lambda.
That is one of the use cases. Yes. And it definitely fits perfectly for Lambda. But we also have Kubernetes workflow in there. A example, we have to so part of what we do is tracking how much people are consuming in their houses. So we get the measurement of like, yeah, well, this person is consuming that much of this day, that other is consuming that other much, and we can't do, but for legislation and regulations, we can't actually do that real time. So and we don't have direct access to someone else's metrics. I can just go to your house, for instance, and get your information. There is a government company in the middle that controls all those measurements, and we need to ask them. They return us in batches. So processing the batches actually goes to Kubernetes.
Is it the net management? Net beheer?
It's EDSN. Yeah.
No.
They manage the grid, and also they manage. They know. They control all the smart meters.
Yeah, sure. Yeah. Okay. And taking it back to your talk and the problems you faced and how did you solve and how you solved it. I saw a slide about the golden path. Can you tell us a little bit, or can you tell us what you talked about?
Yeah. Yes.
There.
Yes, of course. So it's the golden paths and the building blocks of my presentation. They're just a snapshot of a snapshot, right? So we have a whole setup, a whole architecture behind it, so that those golden paths are actually possible. And one of them is that we force you to have infrastructure as code. So the concept of infrastructure as code is that, well, back in the days, you could go to your instance and let's say, oh yeah, I need another instance, I need a bigger instance, or I need more machines. And you could go to the console of your cloud provider and, well, change that number, right?
Yeah.
If you want a new service or so, a new database, you go there and you configure it. It's very, very much a manual process. And you can, of course, miss a step. Those like increasing the size of a database or having a new endpoint or so, those are simple. But when you have a very complex architecture, you need to replicate those steps on dev, on production, on acceptance, and you will make mistakes. So infrastructure as code is a way to script your infrastructure. So I know I will need a Lambda, I know I will need a service. I know I will need a load balancer to handle this service, and I know I will need a flavor of database. So I create a script that tells me, like, I need a server in this network. I need a database of this size. They need to be on the same security group so they can talk, and I need to expose that to the internet. I need to have a name server within a CNAME record so that people can type it and access to my API. I code it, and when I deploy, it's atomic. I deploy every time exactly the same thing. We also enforce it to be environment agnostic. So I don't know from my script cannot have hard-coded information in there. I cannot know which account I am deploying from, because then I can deploy my code to one account or the other, and it will behave exactly the same. There are some clever ways of doing it. Of course, you don't hard code the information, but you have the references, right?
Mm-hmm. So sure, yeah.
So let's say I have a IP, a networking ID. That networking ID is exclusive per account, so I would have to hard code it. What we do there, we create some variables in the account. So you get the reference from that variable. So when I'm deploying, my script will go there. I will say, hey, I need to deploy to the public network. So public network, I go to the account, I get the IP. So it's dynamic. If I go to the production account, I also call it the same. So I go there, I get a different IP, and my script knows which account I need to deploy.
Okay.
This is infrastructure as code. So we enforce it by only having the deployment agents able to run those scripts, and the developers in the accounts, they get a read-only role. So they can only see which makes it better for you. You don't feel like very claustrophobic, because when you deploy something blindly, you have this claustrophobic feeling.
Yeah.
So we allow people to see it, and we do deployments as infrastructure as code. This is one of the examples.
Yeah. And also about the databases, I heard something. Yeah.
Databases, those we enforce databases to be private only. So we don't want databases to be public or accessible by someone else. Databases are something very intimate to your team. I host my database. It's mine. I don't want anyone poking or touching my data. So we force people to put those databases in private networks, and we with that we make people to create a contracting layer on top of it.
Mm-hmm.
You don't want to have an outage because someone run a query on your application or on your database and overload it, so it's unresponsive, right? So what you do, you create this API on top of it. You talk, I need to talk to your data. I need your data. So please create an API, and I create this abstraction layer. I know exactly how this API will behave with my database. I have full control over it. And let's say in the future, I want to change the technology of the database, or I even want to change some columns, drop some columns, this and that. I won't harm another team because my only contract is with my API. So as long as my API is returning the same object type, it's transparent for the consumers.
Yeah.
I can change completely the database. I can have no database, maybe in memory.
Mm-hmm.
The user don't need to know because it's interacting with the API. So there are lots of advantages in not sharing your data.
Yeah, it's for bigger applications. That's awesome. But for smaller applications, you have an extra layer.
You do have an extra layer. It's always a balance, right? If you have a very small scope or a small team or so, you don't want to maybe don't want to spend time in building a contracting layer on top of it. But then you need to take into account that you're also tightly coupling applications.
Yeah.
So tightly coupling applications could be beneficial because they are fast to build, they're less complex, and so on. But also, you create kind of a chain effect. If I make something wrong with my database and it goes down, or if I need to migrate it away somewhere else, I need to put it in a different cloud or just change it. Do I really know my consumers? Do I really know the data who consumes this database? I would need to go check the network logs, and even though, am I sure that everybody who have access to this database is connected? Are they aware that I'm going to change it? So also moving it is complex. If, let's say, I drop a index in my database and suddenly another team is having performance issues and they don't understand why, so who is actually the owner of the database? I don't know anymore.
That's always difficult.
That's
It's also with an API, you have to support that. And if your consumer wants something more, you have to change the layer.
That is true, but the API, you're building it for the consumers only and exclusively. The database is not exclusively for a end user or a consumer. It could be that you're using it as a step for your own goal.
Yeah.
Right. So you have your own context. You have your own subdomain or domain in there, and that database could be something very specific for your needs. So in that sense, you don't want to share this information with someone else. You want to have an abstraction layer on top so that you're isolated.
Yeah.
Yeah.
Awesome.
Yeah. So what are the next steps?
Well, next step is finishing the migration, right?
Yeah.
So we went through a very drastic re-architecture, right? We went from 4 accounts where everybody was connected together, so everybody had access to all the databases and very tightly coupled, to more than 80 accounts. We aiming to more than 100 accounts to the end of this year. So that is quite a drastic change, and a architecture change. We changed the concepts, and that's something hard for people to change. So previously, we had a lot of resistance. Like, I don't want to create a API layer on top of it. I don't want to have these. I can just give you access to my database and you go do it. It's fast. But it doesn't protect your environment. So we forced this extra layer, which is much more effort. And not all applications can actually do it. There are many applications that are tightly coupled to that database, and that database can't migrate. So what we have at Essent is two environments. We have the legacy environment where the critical applications are still running in, and we didn't yet have the time to rebuild them into the new architecture. And we have the new architecture that is almost like a greenfield. So on this new architecture, we are very restrict with the golden paths. So you can only go to this new architecture if you fit in there.
Yeah.
If you have a legacy application, you want to do a lift and shift in there, but it doesn't fit the methodology, you will not go. So you need to plan a migration, you need to plan to rebuild it. And for these, the next step, we're aiming for around 2 to 3 years migrating all the applications and then running only on the new environment.
Okay, cool.
Yeah, but that's also fast.
There are a lot of people working
for an environment like this. Yeah. Yeah, but also you need to take, of course, sustainability into account, building a new environment, and that's good. But I saw that your colleagues also have a talk about that here, right?
They do have a talk. I can give you a spoiler alert. What we're doing there is to actually monitoring the applications that are running on idle, and if the team allow it, we shut down then automatically when it's weekends or so. So mostly we do that on non-production environments. So if it's weekend, why do you have hundreds of machines running on idle if no one is actually coding on it? So what we build in there is a clever way to go through the non-production landscape, checking the machines that we actually pre-authorize to shut down. And during the weekends, we shut down then when the week starts, like Monday, 7 a.m., that we will spin up all those machines again. And it saves quite a lot of resource.
Yeah, I can imagine.
Cool. Okay, I like sustainability. But yeah, cool.
Yeah. Well, Nicolas, thank you for time to having this chat with us. And we're going to follow this development very closely and hope to talk to you again in the future.
Yeah, definitely. Thanks a lot for the invite. It was quite fun to talk in this podcast. So thank you.
Okay.
Thank you very much.
See you.
Yes.
See you later.
Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl via Spotify, Apple, Google Podcast en alle andere favoriete podcastproviders.